Okay, hi everyone. Welcome to the Python for Bioinformatics and Advanced Computational Toolkit class demonstration video. And over here, we'll be explaining a little bit more about the course as well as have a hands-on session at this very moment. So first of all, what you're going to learn in this Python course is Python setup, scientific computing frameworks, NumPy, and core programming for biological data, including data wrangling with pandas, biological data visualization with matplotlib, seaborn, and plotly, and basic RNA sequencing analysis in Python, and then we jump to something more advanced, such as core machine learning tools, which can be very helpful in bioinformatics. So our slide looks like for the module one, it will pretty much look like this, where we carry out our classes in a slide deck and we'll cover Python setup, scientific stack, and Python and NumPy fundamentals. And we will also be carrying on the class sessions, which will take place on Saturdays, 7:30 p.m. to 9:30 p.m. Indian Standard Times for 4 weeks. And the materials includes a slide deck, something like this, code along or hands-on sessions, and a wrap-up class that ensures that you end the class with all your doubts cleared. And our sessions will be held on Zoom. We might also be having either emails or Slack channels to clarify any further doubts after the class or the Friday before the class starts on the Saturday morning. So now we're going to start a hands-on session. So code along with me. So for today's session, we will learn a little bit more about NumPy's vectorization approach in mathematical operations. So the first thing we need to do is to import the necessary libraries, which is import NumPy as MP. We will also be importing time. Now, for every coding session, we need data. So let's create a dummy data set which has 150,000 data points. The first thing we're going to do is to create a data list. So we will convert this data into a list which has 150,000 data points. At the same time, we will also create a NumPy dataset by simply using the NP library that we have just imported and converting that into an NP array, a NumPy array. Now, what we want to see is what is the difference between applying a mathematical operation to values in a list versus a NumPy array, and what are the advantages of using a NumPy array. So first, we will start the timer. We'll call it start time. Since we have imported the library time, we might as well use it. We will create an empty list, which is called result loop. Now, what we want to do is we want to apply a mathematical operation for each value in the list that we had just created. So, and append those values to the empty list that we have created called result loop. So let's start the for loop right now. For I in the data list, we are going to append a mathematical operation to each value in the list. And at the end of it, we want to stop the clock. So we'll call it loop time equals to time minus the start time. So what does this do? It helps us to calculate how long did it take for this mathematical operation to be executed for each value in the list. And now we're going to do the same thing, but using the NumPy array that we had created. So now we're going to start the time again. We'll call it start time. And we will create a new vector and we will call it the result vector. And now we are going to apply the exact same mathematical operation that we had added to the loop, but this time to the NumPy array. So the mathematical operation, as you can see, it is to the power of 2 plus 8 multiplied by the value itself plus 7. And now we will stop the timer again. So this is how a code along session happens, where we will code along together and learn concepts together. And now we are going to print how long it's going to take the for loop as well as the vectorization approach, and we can compare the differences to see why a NumPy array could potentially be helpful in this scenario. Here we're going to create a string which prints out for us the time that the loop took and the time that the vectorization approach had taken. And once you're done, you can run the cell and you'll be able to view the results in the printed format. So as you can see that the for loop takes 0.1 seconds, but the vectorization approach takes only a fraction of it. So this is a good example of a code along session that we will go through, and many more code along sessions in the modules to follow.
Okay, moving forward, you had a glimpse of how our code along session would be. There are other topics which we'll cover. One of which is Conda, which is a command line tool that helps you install all the softwares and keep different projects separate from each other. It avoids breaking the scripts, and you will have every other softwares or Python packages and libraries you need in one Conda environment, so you can run the script easily without any having any debugging issues or errors. Why is it useful? It's because different projects need different softwares and different packages. And if you update one package, it might hinder your other projects uh, easily. So it does not affect the projects you have, uh, and also it's useful to have every softwares and install packages in one environment. How you can create the environment is using the command conda create dash dash name, where dash dash name is a flag. My environment, where in my environment can be any name you can give, like let's say suppose I give conda create dash dash name bioinformatics. So you have created yourself an environment named bioinformatics. Now you can use conda activate bioinformatics and install all the softwares and packages you need so that you can run the Python script. Key takeaways here is it's easy software setup and there's no conflict between projects. Moving forward, as Trisha mentioned, we also have hands-on apart from code long. So hands-on session will include the, I'm sorry, hands-on session will include the publicly available data set, either from TCGA or from the research paper, which is already being published. We will learn how to clean the data, how to wrangle it, how to import or read and write the common formats like CSV, TSV. How do you do? How do you handle missing values? The data type conversion, if it is a string, how to change it to list, how to merge and join two tables so that you can move forward with your analysis, uh, the visualization of plots using Plotly, Matplotlib, like violin plots, box plots, and heat maps, as well as how do you do bulk RNA-seq analysis. So we'll touch base with using how do you use Python package called PyDseq2 for running the RNA-seq analysis, and how do you do QC plots, functional enrichment or pathway enrichment using the GCP or Go and KEGG pathway enrichment. We'll also create volcano plots, which is usually if you have read research papers, you see volcano plots being present in the research paper. Our module 4 would be core machine learning in bioinformatics, which will include the key concepts like how to do train test splits, and how to evaluate the model which you have created how to do PCA, TSNE, and UMAP for dimensionality reductions. And moreover, supervised learning such as random forest or logistic regression with the same publicly available data set, the parameter tuning and hyperparameter tuning as well. Also, lastly, you will after these 4 weeks of courses, you'll have an assessment and a certificate will be provided if you score more than 70% and above. For more information, you can explore the website given in the flyer. Also, you can contact the WhatsApp number here. And if you have any other doubts or clarifications, you can DM us on our LinkedIn pages. If you're interested in any of these classes, please register. Please do register today, and the registration closes at 7 July 2026. So please register before that.
Yes, so if you're interested in any of these courses, please sign up today. Thank you.